Hello method students. In this video we're going to go through a few more examples that are to do with graphs of sine and cosine, but in these questions we're kind of working in reverse. We're using some information about the graphs to try to determine what the equations of those graphs are. So let's get stuck into it. In example 17 here we're being asked to determine the equation of the positive cosine function whose amplitude is 3 and period is 4. So what we look at first, I guess we say it's a positive cosine function, so we know that it's going to be y equals something in front of cos and then something in the bracket. We know that the amplitude goes in front, so if the amplitude is 3, this is 3 cos of something, and we're told it's a positive function, so we write it as positive 3. The period is the other piece of information that we've got. Remember that when you have and this goes for sine or cosine, let's say y equals sine or cos of nx, then the period will be given by 2 pi over n. Right, and so in this question what we're saying is that the period is 4, and so if 2 pi over n is our period and that equals 4, well then that means 2 pi equals 4n, and therefore n equals 2 pi over 4, which is pi on 2. So we know that the n, the number that's with the x, the coefficient of the x, is pi on 2, and so therefore our rule is y equals 3 cos of pi on 2 x. It's probably not a really well written example because technically speaking there's lots and lots of possible answers, because we could take this graph and translate it vertically or horizontally and it would still be a positive cosine function whose amplitude is 3 and period is 4, but for the sake of the example this can be our answer. Moving on to example 18, this time we've got a picture. It's just asking us to state the rule and domain of the graph shown. So you can see it's a graph that starts at the origin and then goes sort of up to +1 and then comes all the way down to -1. So at its most basic level it looks like it's a positive sine graph. Okay, so we can kind of make that mental note first, that it's a positive sine graph. It doesn't look like it's been translated up or down, so we don't have a +c or +k or anything like that at the end of our rule. Its amplitude is 1. And the period, if we look at how long it takes this graph to go through one cycle, starting from the origin, it goes up, down, back up again, it hits the x-axis again before sort of starting a new cycle at pi. So the period equals pi, which we know, as we talked about in the previous example, we know that the period is equal to 2 pi over n. So if we take this equation, pi equals 2 pi over n, and solve that for n, we'll know what number to put into our rule. All right, so we can say that n pi equals 2 pi, and dividing both sides by pi, we just get n equals 2. And so the rule for our graph will be y equals, we said it's a positive sine graph with an amplitude of 1, so it's just sine of n is 2, so 2x. There's no vertical translation that we need to factor in. The only other thing we have to do is state the domain. And the domain, well, you can see that the graph starts from 0, goes to 2 pi. We'll assume those endpoints are included because there's no open circles, so our domain would be x is an element of 0 to 2 pi with square brackets to include those endpoints. And last example in this section, example 19, we've got a function f of x equals a cos of nx plus k, so a few unknowns in this rule. We're told that it's got a maximum value of 11 and a minimum value of -1, and it's also known that f of 1 equals -1. And with that information we have to find the values of a, n and k, which are all positive real numbers. So we're not required to sketch a graph, but it might help to at least in our heads picture what's going on here. We were told that the function has a maximum value of 11, positive 11, minimum value of -1, and so if we imagine a cosine graph that's bouncing up and down in between those two values, well, the mean position, the middle of those two values, you can sort of do by inspection or you can actually average it out, but the mean position would have to be 5, right? Because it's 6 numbers below 11 and 6 numbers above -1, or you could actually do 11 plus -1 divided by 2, so average the two numbers out, you get 10/2, which is 5. All right, so we've got a mean position of 5, which tells us the value of k. We also know from this that if our graph is doing this sort of thing, the amplitude, which is the distance from the mean position to the maximum and from the mean position to the minimum, will have to be, well, 5 to 11, that's 6, right? Or 5 down to -1, 6. So we know that the amplitude is 6 and that the mean position is 5. So at this point we might say, okay, well, let's write what we know, and that's that our rule can be given as f of x equals 6 cos of nx plus 5. Okay, mean position of 5, amplitude of 6. What we don't have yet is the value of n, and the piece of information we can use to find n is this f of 1 equals -1. All right, so in other words, when our x value is 1, our y value, our function value, is going to be -1. So we're going to sub that point in, which is usually what we do when we're trying to find an unknown in an equation. Sub in x equals 1, y equals -1, and see if we can solve this for n. So we get n times 1 in the bracket, and the equation we're trying to solve is this one here. So let's take the 5 over, divide both sides by 6, and we're going to get cos of n equals -1. And if we're thinking cos of an angle equals -1, well, the way we work that angle out is actually to think of our unit circle. Remember that cos theta is right off the x-axis in the unit circle, and if you're thinking about on the unit circle, where does cos theta equal -1? Where's the x-coordinate -1? It's over here at pi. Okay, so our angle is pi, which means that n is equal to pi. And technically speaking, there's actually lots and lots and lots of solutions, an infinite number of solutions to this equation. We did get told that n had to be a positive number, all right, so we're going to give a positive answer. Technically speaking, without that restriction, n could have been -pi, or you could keep going, right? N could be 3 pi or 5 pi or 7 pi, but for the sake of keeping things simple, let's just give the smallest positive answer that satisfies all of the conditions in the question, and that is if n equals pi. So, last job is to read the question carefully and make sure we're answering it. So the question said, determine the values of a, n, and k. It didn't say to write the rule, it just said to determine the values of a, n, and k. So at the end of our working here, let's make it really clear. A was equal to 6. That was what gave us the amplitude. K, which was the mean position, was equal to 5. And n is equal to pi. Okay, so as always, in a question where you've got a fair bit of working going on, make sure your final answer is nice and clear so you get full marks from the examiner. And there we go.